Here's a bigger diagram of what's going on. Now, this is a regular octagon, which means that the interior angles inside are 135 degrees. You can get that by doing the number of sides minus 2 times 180 and divide by 8. That'll give you 135. And this is useful because that's 90 and therefore this is 45. And what we'll get if we start drawing lines down the regular octagon, splitting it into isosceles triangles, this would be 90, so this will be 45. So it's a right-angled isosceles triangle. There's actually going to be 4 of them. Now, we're just interested in the ratio of the area, so I'm just going to let this equal 1 and this therefore equal 1 and work in terms of that, okay? Because it won't matter. I can just, it won't matter as I scale it up or down, the ratio will stay the same. 1 is just quite a simple number to deal with, and it will leave me a root 2 over here. And therefore, all the sides of the regular octagon are root 2. That's useful because now we can find the area. For example, this area is going to be root 2 times 1. And then this area is going to be half times 1 times 1. It's going to be a half, and this is going to be a half. And so the area of the trapezium, or shaded area, is going to equal root 2 plus 1. And now I need to know the total area. Well, I've dealt with this bit, and this bit is going to be exactly the same. So I can just say that it's 2 times root 2 plus 1. And then if I add on this is another root 2, and this is another root 2. So 2 root 2. And then finally, don't forget this is root 2 and this is root 2. So this area here is actually going to be 2. So 2 root 2 plus 2 plus 2 root 2 plus 2 actually get 4 root 2 plus 4, or 4 bracket root 2 plus 1. Which means when it comes to finding the ratio of the area of the shaded trapezium to the ratio of the whole area, although it looks awkward at the moment, we can just divide through by this root 2 plus 1, and it's simply going to give 1 to 4. Neat. No, I'm going to, that's a really good way of doing it. I'm going to show you the way that I did actually. It's probably not as good, arguably, but I again recognize that this was 45 degrees. Okay, that was quite important, and I drew some lines going down. Um, and then instead of making this equal to 1 and this equal to 1, I actually made the length of the octagon be 1. And then if you follow through with Pythagoras, it's going to be x squared plus x squared is 1. You can get x is actually 1 over root 2. So this length here is also 1 over root 2. It's just a different approach. I don't think is as good, but it ends up with 1 on the outside rather than root 2. So what I actually did to get the shaded area then is to work out the area of the trapezium, which is a half a plus b times h. That is a formula to learn and to also, it's worth looking into how to prove that. I'm not going to show it here. So it's the shaded area. I'm just now calling it the area of trapezium because I'm using that formula. So it's going to be a half, and then I'm going to get the top one is just 1, and then the bottom one is actually going to be 1 plus 2 over root 2, and 2 over root 2 is in fact root 2. And I'm timesing it by the height, which is also 1 over root 2. So that gives me 1 over 2 root 2 over 2 plus root 2. So yeah, it's not as nice, but it will still get us there. Total area we can work out. Maybe do it in a different color actually. So in the same way as before, I can just double it to work out this bit and this bit. And when I double it, that's going to be, I can just get rid of that. It's going to be 1 over root 2, 2 plus root 2. And then I can see that I've got a rectangle with height 1. And remember, I've already worked out this base. It was, what was it again? I've already forgotten. It was 1 plus root 2. So it's going to be 1 plus root 2 here. Now I'm going to go straight for the ratio, like, rather than simplifying it. So 1 over 2 root 2, 2 plus root 2 to 1 over root 2, 2 plus root 2 was 1 plus root 2. Yeah, and to be fair, it's not going to simplify quite as easily. Well, what I can do is just times through by, what should I times through by? I think 2 root 2, in fact. So when I times this by 2 root 2, I'm going to get 2. I have to times each of the terms. When I times this term by 2 root 2, this is going to be 2 bracket 2 plus root 2. When I times this by 2 root 2, I'm going to get 2 root 2 plus 4, because 2 root 2 times root 2 is 4. Then I'm going to get 4 plus 2 root 2 plus 2 root 2 plus 4. And you can kind of see the same thing happening as before. I'm going to get 8 plus 4 root 2. So I can factorize the 4 out. And that's going to leave me 2 plus root 2 here. And hence I'm going to get 1 to 4 as before. So like I said, yeah, this way's better, but I just wanted to show an alternative approach. You know, there's different ways of doing problems, isn't there? And as long as we get there, that's the main thing. Good.